Okay, again, our condensate, when it is dumped from our gas production unit, it'll, by a difference of pressure and isolation valves and how we're controlling direction of flow, we have the condensate line set up to flow towards the sales side of the facility. So anything in the installation is going to be the condensate flowing this direction over to our sales side of the facility. You kind of see it's going to co-mingle back with our gas stream on the unit. The third stage or phase of the unit is going to have the gas, and that's going to be discharging through this side of the gas production unit and co-mingling in with our condensate, and everything will be into our outlet final separator vessel. So in this vessel, we're going to have all of our gas flowing out the top of the vessel, and all of our condensate will be accumulating into that vessel with a dump controller set to where if it gets up to that level, it'll trip a float control device and exit through a little bit of a differential of pressure back into the gathering system. Everything will co-mingle back together and head towards the compressor station at that point. We do have some devices, which is a little hard to see right now. There's a device here that's used to hold back pressure on the facility. Helps us control surges and pressure and flow based on how much pressure we can hold back on the facility. So it does help control surging quite considerably, which holds back some sand, and we feel it helps the longevity of the well's production by eliminating those surging conditions. Again, we have our back pressure valve, which is holding a certain amount of desired pressure on the upstream side of our production equipment. Downstream, we're basically at the mercy of whatever pressure the compressor station has on the gathering system. We have a second device here to hold a little bit of back pressure on this vessel, anywhere from 15 to 30 pounds. Currently we're not flowing, so we're not holding anything, but 15 to 30 pounds to be able to get the fluid that's accumulated in the outlet separator back into the gathering system. Again, we have safety devices with pressure relief valves. If for some reason this device was to fail, we have a transducer above our dump controller that's going to give us a high level alarm to let us know there's something not working properly. We'll get an alarm, come out, have to address. Mainly the winter time is where we have problems. We have oil flowing through these lines, very known for freezing in the winter months. So we'll fight. We do have heat tape wrapped, electrical heat tape wrapped around these lines to keep some heat trapped in there to eliminate that issue. We also inject a little bit of methanol. What's in this tank? We just inject a couple injection points on the differential controller, and once we get more onto the sales line, we inject on a Y strainer, upstream of a Y strainer, to help flow and eliminate freeze-offs in the wintertime to keep production moving. To kind of go over that outlet separator a little more, very similar to our three-phase separator in our gas production units. We're using this to separate gas and the condensate. If we do get some water carried over, we'll skim that off the bottom, send it over to our water production tanks. Oil or condensate will be discharged or back into the gathering system, which is this 2-inch line. Some safety devices, what they call a slam shut valve, helps for overprotection or overpressure protection. If we get up to a certain, this is a 720 system. This is set to go off at about 720 pounds. It'll trip a flapper in that check valve and stop flow. We'll get an alarm and come out and address it. Just like on our gas production units, have a Coriolis meter on the sales side. This is energy transfers line midstream. This is how they'll monitor all the condensate coming off of this well pad before it goes into the gathering system. This is the main cash register as far as energy transfer is concerned. This is how we get charged per barrel to utilizing the gathering system. The Coriolis meters inside the gas production unit is how we track revenue for each individual well. So this will monitor everything coming off of this well pad. Our dump controller gets to the point where the float trips the dump valve. This is the valve that's going to open to allow that fluid to commingle back into the gathering system. Basically, we're tying right into what we have here is some pig launchers and pig receivers coming from different well pads and going from this pad over to the compressor station. The gentleman from the midstream group will run pigs and receive pigs daily based on the amount of fluid and production we're moving. They'll run a pig and just sweep the line going to the compressor station to help sweep any fluids that has accumulated into the gathering system over to the compressor station, where they'll treat it there. They'll let it stabilize, settle into the tank, and get it hauled off, where at that point we'll get a load ticket on the amount of condensate production that they're hauling off, is how we get paid for that condensate off of each pad. And that'll be allocated back to the well pad based on the Coriolis meter measurement. And all that data, like I said, is going through that PLC. We have a SCADA system that tracks all that data. SCADA stands for Supervisory, Controlled, and Data Acquisition. That's the device most producers use to acquire data, build a repository, reports, and for revenue purposes. We also have an app on our phone that we can track any production coming off of SCADA as a tool, be able to check alarms, reset alarms, and monitor current flows.